So let's have a look at this guy. In the first case and the second case. To identify acid conjugate base pairs, the first thing you need to do is obviously identify the pairs. That should not be that difficult. This guy and this guy are a pair, and obviously this guy and that guy are a pair. Similarly, this guy and this guy are a pair. So you have identified the pairs, and now you just need to figure out if this is an acid or a base. And the way to do that is this. Acid is a proton donor. If something donates a proton, right, what happens to it? Does it become more positive or does it become more negative? I've just given away a positive charge. If I've given away a positive charge, it means I've become more negative. So an acid becomes more negative. And a base, consequently, will become more positive. So we have a look at this one, we see it goes from there to there. It's going from a charge of -1 to 0. Is it becoming more positive or is it actually becoming more negative? It's actually becoming more positive. So this will be an acid, and then this will be the conjugate base. And so therefore this will be the base, and this will be the conjugate acid. In this equation over here, if you have a look, this guy is what? This guy is becoming more negative. He's going from a charge of -1 to a charge of -2. So therefore, it becomes more negative. It's an acid. What did I do? Sorry. I'll just take that back. This guy is actually becoming more positive. And if it's becoming more positive, this has to be base. My apologies for that. I didn't see that. So base, acid, conjugate acid, and conjugate base. I'm sorry if I confused you. I just made a mistake over there. So this guy is obviously becoming more positive, and this guy is becoming more negative. So this will be an acid, conjugate base, and this will be a base, and I'll have a conjugate acid. Alright? The second interesting thing to see is this. This guy over here, in the first equation, is acting as a base. In the second equation, he's actually acting as an acid. What? So what is it? Is it an acid or is it a base? Well, if you just look at it, something that can act as both an acid and a base is actually called an amphiprotic substance. So an amphiprotic substance is something that can act as both an acid or a base. One example, you've already seen, HCO3 negative. Another example is HSO4 negative is another amphiprotic substance. To demonstrate that something is amphiprotic, you can either react it with water, or even better, you react it with a H3O positive and an OH negative to demonstrate its acidic or its basic nature. Again, the PowerPoint has an example for this, which you can just look at. The last thing we're going to have a look at today is buffer solutions. Now, a buffer solution is something that contains a comparable amount of weak acid and its conjugate base. So what happens is, then it can act as both, because it has both the acid and its conjugate base. They are too similar for them to react with each other. However, if you put an acid, the acid will react with the base, and if you put a base, the base will react with the acid, and it will always be neutral. So an example is, let's just say I have a buffer solution that has both this, right? So it has the acid and the conjugate base. Normally when I put an acid and base, and this is actually not separated, they're still in the same solution, right? Normally what will happen is if I have an acid and a base, they will both react and they will neutralize. But in a buffer solution, because it's the acid and the conjugate base, they're actually quite similar. The other thing is there's an equilibrium between the acid and the conjugate base. So let's just say I add more acid. The acid will react with the conjugate base and get neutralized. So what has just happened is the amount of base has just dropped. Because this is an equilibrium reaction, according to Le Chatelier's principle, if the amount of conjugate base drops, the equilibrium will shift to the right and make more of the conjugate base. Similarly, if I add more base, the base will react with the acid, the amount of acid will go down, and the equilibrium will shift to the left. So you can see that this guy can actually maintain a constant pH, even though I might, add a reasonable amount of acid or a reasonable amount of base. As long as this equilibrium exists, the buffer solution can still maintain a constant pH. That is all we'll be looking at today. Thank you.